Today in our information processing tool series, we'll try to discuss the topics related to artificial intelligence, but we'll try to focus mainly on expert systems. Know that we have been talking about number of tools which are required to do any projects in your second trimester. In this week already we discussed RDBMS, ER diagram, and today will be our third one called expert systems now. So basically what we are going to discuss here is that I will talk about what is an expert system, what are its advantages, what are its limitations, what is the difference between conventional software and expert systems, what are the components of an expert system. So for example, when you develop any software, you have a large set of components. We will talk about what are those basic components comprises in the expert system. Then we will talk about the knowledge representation of schemes, that is the basic heart of all the expert systems. So we will talk about 2 or 3 different types of schemes, try to find out the differences and their applications, and finally we'll try to talk about a framework called expert system shape, and then we'll try to answer your questions. So the format will follow the same format what we have decided for our group discussion. At first 15 minutes, first 30 minutes we'll have a discussions on the topic, and then we'll open the floor for any type of questions and discussion sessions now. So basically let me first give you some temporary definitions, some working definition, and then later on I will try to refine these definitions now. And so let's try to give you what is an expert system. Let's say have the expert system contains knowledge of, let me see this definition now. An expert system contains knowledge of experts in a particular domain along with an inferencing mechanism with an explanation subsystem. It is also known as a knowledge-based system. So when we talk of expert system, basically what we mean that it is software, and the basic component of any expert system is what we call the inferencing system, which is able to infer the knowledge, or which is able to infer the rules from the knowledge base and so on. We will talk about what is the inferencing engine for inferencing systems and so on. So this is basic temporary definition, and later on we try to redefine what is an expert system. So now let me once again, that expert system is a system software. In fact, is a part of computer, the part of artificial intelligence. For example, in computer science we come across with lots of branches, and AI is one such branch, and expert system is a part of the expert system, part of the artificial intelligence. We discuss with many problems in expert system. For example, pattern recognition is one, natural language understanding is the second one, and so on, and expert system is one. Now, expert system is one of the most prominent area in the, because it touches all the areas which we come across in our day-to-day activities. And then let me first give you what is artificial intelligence. Let me give you all the basic concepts related to what we call an expert system. And let me talk about first what is artificial intelligence. For example, we take a whole computer science. It is a big branch, big branch of the science. We have a operating system is one discipline, we have a compiler design another discipline, networking another discipline, data structure is another discipline. So therefore the artificial intelligence is another such branch in the computer science now. Now what is artificial intelligence now? How can you define what is this artificial intelligence that is a branch of computer science? Let me give you proper definition of AI. And I told you in the beginning that expert system is one branch of the AI now. Now what is AI now? AI or artificial intelligence is the part of computer science concerned with designing intelligent computer systems. That is a system that exhibits the characteristics that associate with intelligence in human behavior. So basically what we are talking about is that we develop a program or develop a solution such a way that it behaves just like a human expert. Sometimes, for example, game playing, sometimes writing a game, like chess playing. Sometimes we have seen that the computer also plays games. Writing a program of this nature is not ordinary program, not a normal conventional type of program. It contains lots of rules, and the person who has written the program must have contained lots of knowledge and experience in this area. Then only he can write a program like such. Right? So basically what we are talking about is that the AI is those areas which exhibit the characteristics of a human expert. For example, if somebody is expert in the medical science, somebody is expert in some other branch of the computer science, so he or other areas like a tax consultant or the geologist or physicist or chemist, whatever area you can take up, if he writes a program or if he imparts a knowledge what he has gained during his years of experience, then the program of that nature will be what we call which belong to artificial intelligence. We try to understand, we talk to someone in human language, in Hindi or English, but if computer try to understand the same language in which we are talking to, then it will develop the characteristics of a human expert or with intelligent machines and so on. And lots of other research is going on in this area to develop a system called what we call intelligent system. Japanese had long back, I don't know what is the status of this project, but Japanese had long back come with a project called fifth generation computer. You know that in computer science, any advancement is basically measured as a generation. First generation computer, second generation, first generation of microprocessor, second generation of microprocessor, and so on. So every generation of computer, every development of computer is measured as a generation. So the Japanese had a project called fifth generation computer, and the idea was to develop a computer which will behave just like a human expert and so on. So basically this is what artificial intelligence is, development of intelligent system in many areas you can think of it. Now, so let me define some more concepts related to that, and then we come back what is an expert system, because our topic is an expert system. Now let's talk about what exactly we understand by domain expert, which is always used in this area. Domain expert is the person, let's say this definition, domain expert is the person who has acquired thorough knowledge of a problem domain through years of training and experience, whom we can call domain expert. It's not that somebody has acquired a PhD or the doctorate in another discipline. No, of course that will be the starting stage. But a person in working in a particular area, like 10 years and 15 years, and somehow have established himself in that area, that person can be called as a domain expert. For example, doctor is practicing in certain area for last 20 and 30 years. Anything he does not based on what he has read in the book, but he learns through his years of experience and so on. So that is what we call them domain experts. Not only the knowledge which we have gained from the book, but always to practice and the real life situations. One derives many other situations, derives many other solutions which you will never find in the textbook and so on. So those type of people are called domain experts. Now what is knowledge representation? That is another important area. So lots of research in the AI area is towards knowledge representation. So because this is a little bit different from other areas. In other areas we basically, for example, we have a database management system, right? But here we are talking about knowledge representation system. So something is a bit different from the database representation. So lots of research is going in this area in AI is how to represent the knowledge. Now you have learned something from your database, how to represent the data, right? Data, how to do data modeling and so on. But here we are talking about how to represent this knowledge. If this one happens, then such thing can be thought of and something like this. If you have developed this type of symptoms, then this type of disease can be diagnosed and so on. So we are talking about that type of expression, and that is called knowledge. So what is knowledge basically, and how? Let's talk about this one first. Knowledge representation is the process of formulating or viewing a problem which makes it easier to be coded in a computer language for further reasoning. I told you that many skills which we are able to talk about today, and basically you have to represent your knowledge such a way that it must be able to model them into the computer languages, right? For example, what we have discussed earlier is that, for example, take example of last time we introduced a concept called ER diagram now. Now ER diagram was, you know, that each entity can be easily represented in form of the tables and so on. So basically what we are talking about is that you have to represent your knowledge such a way that mapping them to this one, to computer languages must be very easier. And just for your knowledge that there are lots of computer languages are there, especially only for the AI type of problem solution. For example, Lisp is one such programming language. Prolog is another such programming language. They are basically designed to solve write a program of expert systems sort of things and so on. So this is what we call them. So we have defined two important concepts related to this area. One is what is AI, second is what is domain expert, and thirdly what exactly we understand by knowledge representation. And then what are the basic components of an expert system? The component of any expert system, we are not talking about any specific now. So the component of any expert system which contains components are there, we'll try to list them. But one such component which contains the knowledge, right, then it is called knowledge base. It's somehow very similar to what we call them database. Database, we call them all the information are in form of numeric, your age or your salary or your name and so on. But here each component of your data or knowledge base is sort of knowledge. If then form might be. If this one, then this is. If you have a headache, then anything can be prescribed. So this is one such knowledge or one such component into knowledge base. So one of the most important components is called what we call the knowledge base. And how you put your data into knowledge base, you have to use certain knowledge representation schemes. The another important area of another important component of an expert system is what we call them an inference engine. Now what is inference engine? Inference engine decides which part of knowledge base is relevant to given current situations, and then it applies base rules. It is also called control structure. It is job of the inference engine to find out a particular knowledge based on particular rules. Basically, like for example, lots of all these search engines you have, like for example, Yahoo is a search engine. Now Yahoo search engine also has somehow this type of technique is built into it. So you fire a query, and based on this query searches for the information and so on. So they are also built on the AI techniques and so on. So must you understand that when somebody is designing a search engine type of project, definitely one is basically designing inference engine sort of thing. So same logic is applicable there also. So something more might be added to it. So the basic heart of search engine or might be the inference engine is that somehow what we call them is much more is to look for a knowledge or information based on certain data available to it. And so inference engine knows which rule to apply for find out what type of data or what type of knowledge based on what type of data which has been provided by the user. So user provides certain data that he has developed this type of symptom, please find out what type of medicine should be prescribed. So now this is job of the inference engine and to find out that what type of diagnosis must be or what type of medicine should be prescribed to this type of person in this type of situations. And then you have then what we call them the interface now. So another component is called interface. Just like for example, we always develop when you develop a software, whether you develop a two-tier architecture, whether client server architecture or three-tier architecture where middle layer is there. In client already what you put into the client software, you always put an interface. That is what the current trend is. That you always your client software is always must have only the interface part of it. How you are trying to interact with the system. So when you develop an expert system, so which you interact with the whole system is what we call them the interface. So interface has also to be designed. So what we have listed now is, I think you must be able to visualize now, is the three basic components of an expert system. One is what we call them the interface. The second one is what we call them knowledge base, and third one is what we call them inference engine. Let me show you through this diagram. Here is the user interface. This is the knowledge base, and this is the inference engine. Now something one is missing here. I think you must be able to make out what is missing here. There must be link from the inference engine to the knowledge base, because inference engine has to look the knowledge from your knowledge base. There must be certain linkage. That linkage is missing. So when you draw your diagram, you try to connect the inference engine with the knowledge base. So that is one small mistake we have done this one. We try to take care of it. What are the basic components of an expert system? Let me try to answer the second question we raised. Remember, we are trying to answer. We are not going into very much detail. We are trying to explain you this concept so that you can use this one. We try to understand that this is also an important tool for information processing which is required for computer solutions processing. So now let's try to understand then what is the difference between then you can raise a question. Do you think that the program which you write does not behave in intelligence characteristics? Not necessarily. Of course, it is somehow you can say they also behave in that fashion, but what we are looking for in expert system is entirely of different kind. Now, what exactly now? In conventional program, reasoning mechanism and domain knowledge are interlinked. Just by face value, the structure right now I am talking about. So both are basically linked, both are interlinked, both are part of the same. But in ES or expert system or the knowledge-based system, these two are two different components. You have to entirely do two different things now. This makes the program much more modifiable and comprehensible. So when you develop an expert system, knowledge base will be one such component, and what you call them, but here an inference engine is what we call in another way. But when you write a normal program, everything is built into it. I am just giving, just to simplify this one, of course, is not a right example to explain this concept, but you must understand that when you write a program in conventional programming language, that is C language, what you do there is that you write a procedure at one side and data at another side. So both are not combined together. But when you write a program object-oriented, both are put at same component, methods as well as data on which this method are to be applicable. They are as a part of the same. This is what we are talking about from that context. With one place both are separate, another place both have mixed together. Expert system, the another difference is the expert system has self-knowledge. Once it has reached a specific knowledge level, it can explain how it is reached there. That is logic. It gives you how we came to this solution. That if I have developed this type of symptom, then this digit this is the correct medicine prescribed by the expert system. How it came to this conclusion, it can give you this whole sort of reasoning also. So more reasoning is built into it. If it asks for some more additional information, then you can explain why does it need it. So when suppose the system is not able to come to particular conclusion, suppose that you are asking for, you have developed this headache, for example, there can be many reasons, there could be many reasons due to which you have developed headache. It might be the eyesight problem, this eyesight gives you a headache, or you have a cold, or you have got a cold, that also can be true. So system can ask you many other queries before coming to the main conclusion, which you sometimes don't find in the conventional type of system or software. The conventional program works with numbers, age is one number, the salary and so on, and do the numeric computation. Most of the programming language of this kind, which supports the conventional programming software development, they support you more of the numerical computations. Whereas expert system work with symbols, just like a human expert do. If then else type of situations, you always think of it. So one deals with numeric problem, another deals with the non-numeric problem or symbolic problem. This is the third major difference between two types of program. Now what are other advantages of artificial intelligence or even otherwise, or artificial expertise or expert system? That is permanent. Once you have built the logic into it, then it will always be permanent. But sometimes we human beings are not very consistent. Sometimes you can forget your rules of your logic, or sometimes depending upon situations you react different way. But once you have built your logic into this computer, then computer will always behave the same way. This is another important advantage with the AI and so on. So this is fourth major difference. Now so right now we have given you some advantages or disadvantages, you can say, but of course you have disadvantage also, that the expert system is never able to replace a human being, because always it has to rely on the situations now, so whatever knowledge it has been built into it, he basically work on those rules. But if new rules has come, human expert can pick up very easily and so on, but the computer expert has to rely on the human expert. So this is basically is never able to match the capability, but you have some other advantage you have seen now. Now let's talk about the third problem which you have talked about, is what we call the knowledge representations schemes now. And so what the knowledge representation schemes deal with it? But any knowledge representation schemes, which I will just simply introduce two or three, they deal with this type of issues now. Expressive adequacy. What exactly it means by expressive adequacy means that how much knowledge is required to come to the solutions now. Remember how the knowledge is represented, basically how much knowledge should be given to come to a particular solution, or with less knowledge also system can be able to come to particular solutions or not. the reasoning efficiency, how much the reasoning has to be done by the inferencing engine, whether by, even if the data is not complete, whether the system will able to do the proper reasoning or not. Because so the one important thing which we try to understand is that when we talk of this per system, even if we are talking about this, even if we don't have the complete information, system must be able to give you some solution for such a mistake. So incompletely, whether the information must be complete or whether data given to the system must be complete, even half of the data can also be sufficient enough to represent the knowledge, or you must be able to get some solution from this one. So basically, any knowledge representation schemes must be able to deal with this type of situations. And the last one, real world knowledge. Can we believe all types, can we express all types of situations through knowledge? So the 4 or 5 situations are very much important, but how much information must be given, how much reasoning must be there, whether information must be complete or half of it is also sufficient enough to get you something from the expert and so on. Or somebody, like for example, what we are talking about is something like this, if you are not able to understand the basic problem is, but you have seen some doctors are very expert, even if you are not able to explain everything, then you will be able to give you certain this one. I know that some doctors, what they call some, they have developed such a sixth sense. The moment you walk in and they are able to diagnose what type of problem this man has without asking you even at what type of disease we are going to talk about. So basically, there are some, or you give you very half of the information, they will be able to retrieve everything from you with this type of information. So knowledge representation schemes must be able to capture everything. And so basically, what are those schemes are there? And these schemes are called rule-based representations. This is one set of schemes which is quite popular now. Most of the express systems have built into this type of system now, rule-based representations. They have a frame-based representations. They have a semantic mode. So there are 3 or 4 logic are there, 3 or 4 schemes are there for representation of knowledge. The rule-based, frame-based, the semantic mix, and the knowledge representation using logic, what is called the predicate logic. So various ways you can represent your knowledge. Just like, for example, you have various modeling schemes. For example, you use DSD sometimes for data modeling. You use sometimes what they call the ER diagram for data modeling. Or if you talk of the object-oriented system, then again you have many data modeling schemes, what we call them, the BIT model, the another model, the Rambo model, and so on. So there are many other models are there through which you can same way the KR schemes are many, and depending upon some situation, I have just listed few most popular ones, and more are coming up. For example, probabilistic reasoning or fuzzy representation schemes and so on. So more schemes have been already devised. We'll talk about the some of them very quickly. The easy, now rule-based basically, they put all your information in form of if, then, else. If you have this one, then do this one. If you have this one, then this could be medicine. If you have this disease, then this are the following medicine. So basically, easy to provide knowledge in the form of rules. Rules means if, then, else form. Difficult to maintain a large number of rules, but what happens is that having found that if you are trying to represent your knowledge in form of if, then it becomes quite complicated one and is very difficult to maintain. Sometimes unstructured, which is basically unstructured type. For example, sometimes you remember what exactly you understand by unstructured. For example, you say C and Pascal are called a structured programming language. They somehow remove the basic type of statements. But earlier programming language have lots of basic statements like basic programming language called basic. They are very much relied on basic type of for control structure now. So those type of programming language which are heavily dependent upon the basic for control pattern are called unstructured. But here the same thing, the same type of situation one come across when you use lots of if, then, else. So this is one of the drawbacks, but learning is much more easier. Even the first system, who is not an actual computer expert otherwise in other areas, can easily express his knowledge in form of if, then. So you have this type of disease, you can prescribe this type of medicine and so on. So basically this is this type of rules most of the time in day-to-day activities. And many classical systems, for example, and all these systems, to my knowledge, they have been used for medical diagnosis and so on, called mycine. They all are based on if-then rules. Then another is called frame-based representations. Now, frame-based representation is very similar to what we call them, just like a record structure or an object-oriented type. Like, for example, how you write a program in C language. When you write a program in C language, basically you write a lot of based on your function. All the program comprises the same number of functions, right? But when you write a program in object-oriented, then you always write your program in terms of number of objects. So you always conceptualize your situations in only in terms of real-time objects which you come across. For example, if I want to compute a particular organization, then employees could be one object and so on. Part-time employee could be another object. The full-time employee could be another object and so on. If I'm trying to compute bank, then account could be one such object and so on. Same way, when you try to represent your knowledge using frame-based, you try to think only in terms of frames and objects and so on. So depending on particular type of situation, particular object will be called by the inferencing engine. Now this is the one way to represent the knowledge. Chair, I am trying to put lots of information about the chair. Chair is a furniture, right? So if you have given some information, then chair might be this one. The color is brown. All brown colors of furniture might be of chair type and something like this. The chair is made of the wood. Chair has 4 legs. So if you have given information about leg number 3, then chair will be never be able to retrieve by the inference engine. But with 4 legs, always you can think of a chair if it is made of wood. Now the semantic notes, basically is basically natural language. There is a natural language now. Now this is basically used for that one of the area where this is AI is used to understand the human language, and in that the semantic notes are used. It's basically graph-based structure now. The semantic notes is always used for understanding the English sentence or any type of languages and so on. Also, what I told you in the beginning, there are a number of schemes are there, and all are basically used for different types of situations. So if I want to write an expert system or like a system, AI system which understands the human language, then we can use it to represent the knowledge or the structure in form of a semantic notes. It is used for representation of declarative type of knowledge, right? We have a procedural type of knowledge, but basically we are talking about declarative. But the word declaration, I think to simplify, there are 2 types of languages otherwise. For example, most of the AI are or if you write a program in Prolog, you don't write the way you write a program in normal conventional programming language. It's more called declarative programming language. Basically declare more and so on. You don't use lots of logic for it. The node, so basically how we represent them, we basically represent in terms of each node, we try to represent them in terms of a graph. While each node represents an object or a concept and a link represents a relationship. So everything we try to put them in terms of a graph and so on. This is one such technique are there. And the last example which I wanted to talk about is this one is the predicate logic is another such technique which is used quite extensively for representations of the knowledge. Now what is the predicate logic? Predicate logic is useful for representing simple English sentences. It can also be used for that into a logical statement, but it creates ambiguity for complicated sentences. So this is basically also used quite extensively for natural language representations now. If computer processes a natural language, it must have some mechanism to represent it. Right? For example, all your data which you enter is basically represented in a form of a table. Same way, there must be some structure to represent all the information within the computer. So we talked about the semantic note is one such a scheme, the predicate logic is another such a scheme, and so on. So there is a way one can apply, but depending on situation, one can use them. Like for example, I have something like this. This is basically how I am trying to represent a knowledge using a predicate logic. Of course, it might be a little bit complicated, but I will just try to explain to you. Anil is a manager. This is one such knowledge or such information. We deal with information, but when we talk about expert system, we always deal with the knowledge. So Anil is a manager. Anil is a disciplined. All staffs are either loyal to Anil or hate him. Either this one or that one. Everyone is loyal to someone. This is sort of what we call them some information. I have some knowledge which I want to represent into form of what we call them algebraic rules or what we call them predicate logic now. The lots of symbols are there, but somehow we are not explaining you these symbols. Simply give a certain feel that how you represent. Like for example, you have a or, you have a for all, and so on. Let's talk about something like, if Anil is a manager, I will simply put it like this. This is a one such phrase. This is also a predicate logic. So manager is basically, so name always put into the bracket, and this is might be Anil is a one manager. If I have to represent using predicate logic about Anil is a discipline, I will simply say discipline and bracket Anil. And for example, this is quite complicated one, and here all staffs are either loyal to Anil or hate him. How I am representing them? This is the one symbol. Just look at this symbol now. This is the symbol, just the beginning symbol now. This beginning symbol is there must be some here horizontal line here for all x. This way we try to represent now. And this one without the bar, without the horizontal bar, which is as it is called or. So for all x, what we say, for all staffs are either loyal to Anil. So something like, for all staff, they are either loyal to this one or hate Anil. So we're not going to detail, but this is just to give you a feel that how we try to represent the information. So if you want to learn the predicate logic, you have to learn various symbols and rules of how to represent these symbols. And same way, here everyone is loyal to this one. For all x, this is again, this is a bar, y, that is y is loyal to x. So anyway, this is a complete science in itself, so we're not going to detail. Simply see some structure how we are trying to put the information now. And so various strategies are used, how we are trying to talk about, we say the forward reasoning and we say the backward reasoning. Two ways, all the influencing engine works on two basic rules. How do they infer the rules? They are basically what we call in forward reasoning and what we call them backward reasoning. And just like for example, we have lots of searching and sorting algorithms. Same way, there are reasoning strategy are there on which the whole influencing engine has been designed. Now, I just talk about only one such, this one called forward reasoning. Basically, it starts with the data now, and then try to look for some knowledge based on this data. If data is inadequate, they will ask you some more data and so on. So basically, it starts with some basic data and look for certain information based on this data and apply certain techniques and apply any of these techniques. And then again look for some more data and so on and so on. So basically, these are very searching techniques, I will call them, through which they are relying or they are trying to infer the knowledge by applying certain type of rules, whether you have given all the information or less information or information is not complete and so on. So basically what I'm trying to explain through this slide is how we design the inference engine. I told you how we design the knowledge base. I told you that three basic strategies are there, and one such like for example the predicate logic or semantic based or frame based or the rule based. Same way, if I have to design the inference engine, I have to use certain search techniques, right? Such reasoning strategy. I'm simply listing, they're not going into such detail, what we call them forward reasoning, backward reasoning, and depending upon what type of situation we use particular type of reasoning strategy. And this way we try to do this one. And finally, the last thing, what we call them, the expert system cells. That is basically the framework. You don't need to, we list it now. So there are two programming languages are there. One is I call them Lisp, and second is Prolog, which quite Lisp are designed by US, and the Prolog is very much popular in Europe now. So basically, through these shells, you don't need to write a complicated program, and so everything is built into it. The inference engine is built into it. There is a you can easily, the database structure is there. Simply you have to fire the query and so on. You have to simply put the knowledge and so on. So if all the framework is there, simply you have to do very less programming required, and you can develop certain expert systems for a particular area. So most of the domain experts use this type of thing. So it is used by domain experts to build applications. Again, expert system is based on particular rules. Some of the expert systems use all types of rules. Rules means what? The knowledge representation schemes. But some are based on the rule based, some are the predicate logic based, some are the what we call the semantic based and so on. So depending upon situations, you have to look for particular type of shell, and then you can write. Easy to use and do not require computer programming knowledge. You don't require expertise in this area. This is you all we had. Let me quickly summarize you, and then I will have some discussions with you. That I gave you what is an AI, what is an expert system. I told you that expert system is an area of one branch of computer science, one branch of AI, and then we talked about the what are the limitations and advantages of an expert systems, what is the difference between an expert system and conventional software. We talked about different techniques for knowledge representations. We listed 3 or 4. Then we'll talk about components of this one, and finally I will explain you what is expert system. So now I want to entertain your questions now. Yes, please.
What is the difference between inference engine and the search engine?
So search engine, you see the search engine is very, if you see the working, if you want to see how they work in very similar way. Both are somehow same way, but the inference engine is more on exploit the knowledge base. Right? They are basically used for designing or searching the information from the knowledge base. Whereas the search engine, they work both. They work sometimes as an inference engine. They use certain AI type of technique, but they also most of the time they interact with the normal databases and so on. So both are same, but the difference only lies in that the inference engine works more. I mean, they work with more of the knowledge bases, whereas they work with the what we call the normal databases. But they also are based on certain AI techniques. Yes, please.
So in the near future, how much is the chance that the machines that are created by using artificial intelligence will replace human beings?
So basically, I have given you various examples now, like my team I gave you various examples. If I told you in the beginning that the machine is not going to replace the human being. Human being is always will be on the top. But I told you limitations of this one. Lots of research, in fact, lots of the expert systems which have been designed, they somehow in 70% of situations they have behaved just like a human expert, like my team I gave you one example and so on. And there's certain other type of software has been designed which very similar the way you work with as a human expert now. But I can't think that it will be machine which will be able to replace the human being or able to work with really 100% intelligent machine. Yes, compared to what we have, definitely things are improving. For example, today in the network situations, we have what we call the intelligent agents now. These agents are basically, they look for everything. For example, most of the time if you have to do the web surfing, if you don't have to, if you are not able to find the information, then you have to do everything on your own. But today we have an intelligent agent software which is working for in the internet environment, which will look for all the information which you are looking for. Of course, comparatively is much more intelligent than what we have. So yes, recently things are much more, will be much more better than what we have. Yes, please.
Expert system architecture.
The expert system architecture is same. I mean, see, basically what we talked about is that if you have to design an expert system, right, you have to have the 3 components now, right? For example, expert system architecture is somewhere like, for example, of shell. It's somewhere expert system architecture. It's a framework. The question to have in is what is expert system framework? Like shell is one such framework. Now, if I have to buy any shell for writing any expert system, what it comprises of? It has a built into it, its inference engine. It has a knowledge-based system. It has a what we call the interface. So this is what. So any expert system architecture, generic architecture I am talking about, must comprise of 3 basic components: inference engine, knowledge base, and what we call them as the interface. Yes, please.
Who is the knowledge base editor?
Knowledge base editor is basically we have given 2-3 definitions now. What we call them domain expert, right? Domain expert and the editor is basically again some person now who is basically doing some editing job. Now I have also, I think, similar. I explained you another concept called domain expert now. If you are developing a human expert, if you are developing some human expert, then definitely you require a domain expert now. Because the person, domain expert, you get only not by acquiring a very high degree. I give you an example, like even you have a PhD degree in computer science, you will not be called a human expert, because the human expert is those type of people who have acquired his skill after working in the area for let's say 15 years, 20 years, and he applies his rules not what he has learned from the book, but somehow based on the experience now.
What is heuristic programming related to AI?
AI heuristic is somehow what we call it. The two types of things are there. For example, certain type of rules are basically, which most of the industry use heuristic type of situations, rules for solving expert system problems. Some problems are, let's say, we say that it is mathematically tested now. It's based on mathematics now, tested, certain rules, certain such techniques, certain sorting techniques I have designed now. It's based on certain techniques. I have tested it mathematically that if I will be able to do sorting or searching within log to 2 power n. Right? So I have analytically, mathematically analyzed. But certain rules for certain type of problems, there is no specific guidelines or techniques are there. So what they have learned or applied to normal to day-to-day activities, not based on very strict mathematical rules or tested ones, they are called heuristic rules.
So these days, object-oriented programming is basically basically these days softwares are developed using object-oriented programming. Will they replace the structured programming?
Object-oriented is the technology today, right? And object-oriented is the technology. Today, everything is designed around object orientation now. Also, it is structured. Basically, today we don't say the structured now, right? Basically, I will say the linear structure. We are providing the linear structure. Today, see what happens is like this. Object-oriented has become the dominant technology now. It is all the technology today you have. Let's say, for example, you have a Java is designed around the object-oriented programming. C++ designed around this one. And most of the operating system software is again being designed around object-oriented. The real advantage of object-oriented software is that the software development life cycle is much more lesser than what we have in the normal conventional structured programming like C and Pascal. Today what we have seen that every 18 months you have a new type of paradigm you just seen. In hardware, for example, what you have a 386, 486 Pentium, and again different version of a Pentium now. In all the technology, a new paradigm in the hardware came just within 18 months now. Again, it's based on certain law now. But you don't have a software which will able to exploit the hardware. Today you see, for example, if I have to design my hardware, if I have to assemble my computer, it hardly takes half an hour. But if I have to design, even if I have to write 500 lines of code, it is taking lots of time now. So object-oriented is one such technology where software development life cycle will be much more easier than the normal conventional programming. You use the same concept at every stage. You understand? You always conceive your problem in terms of object orientation, and that is much easier than thinking of your problem in terms of computer terminology like functions, variables, procedures, and so on. When you write a program object-oriented, again, what basically you think? Always you think in terms of number of objects and classes, which you use all the time at the analysis stage, at the design stage, at the programming stage, at the testing stage, and so on. But when you develop a software using normal conventional programming language, each time you go to the next phase, you keep on changing with the new terms and so on. That way, the development life cycle, the learning life cycle is much more difficult in other conventional technology than the object orientation. Even in coming back to the expert system, the same based, it is very similar to that one, but you try to do all these things together. Yes, please.
So from where did the concept of development of expert system came from?
I think the first product which claimed itself that this technology or the science could be very viable technology for the industry, it was MySim. MySim is basically some chemical analysis and so on. So basically lots of research came started from the USA now. But Japanese, I told you that they take the thread from what they did in USA and wanted to build a new system for fifth generation computers. It was supposed to be one of the most intelligent machines, but somehow I don't know the status whether this project really worked came to the end result or not. So yes, everything started from the USA now, but lots of research has been is being done into the other countries also. For example, the Prolog programming language, which is one of the most popular language for representations of knowledge, was developed in Europe, not in the what we call them USA. Yes,
USA, Bell Labs are there, where the mostly software development programs are generated. So what are the chances in India that we will be having a lab like Bell Labs?
So right now, today we are talking about alliances. You know that today we have the one sister company of Bell Labs is Lucent Technology. It's very much in India. Already there is one lab in Bangalore and they are working for this one. Today, let's take example of Microsoft. Very much is going to be this next development center is going to be in Hyderabad. Take example of this what we call the another telecommunications companies. Siemens is very much in India. Lots of other companies are coming up in India and people are working. So you can't set up that type of company exclusively because they require lots of investment and lots of people. But now what they are doing is that today we have lots of talent in India and they can work with less price also. So they are outsourcing it. Lots of development is taking place for those industries, those research labs in India itself. Take example of those Photoshop and all those companies. What I don't know what is the name of this company which develops all types of desktop, this type of Photoshop and all sort of things. It's very much in Noida now. So they are developing a software for those parent companies. So it's very much in India now. Not when it will come. Already there people are working for those companies now. Take example of your this Wipro. They are working for the top companies now. Take example of Infosys. They are also working for those companies now. So now no company can think of developing everything. So they have come to India because lots of other people are there. So they are developing for them. Yes, yes.
Nowadays, sir, we are listening one more concept that human brain nerves are being connected with the computer chips. Is it really the part of artificial intelligence?
See, it is somehow very, today, in fact, it is in fact, answer to your question in one line, yes, it is a part of the AI. But let me explain you today, the people are trying to understand there is the another branch of computer science which are somehow trying to understand, I just forgotten the name of that branch, which is basically trying to understand how does our human mind works. Right? So they are basically looking for those type of clues, how really the mind really works. They might design a computer which will be designed based on those type of structure. So it's very much part of the AI techniques now. But I tell you that again, internet has opened lots of horizons for doing research in the AI now, right? I told you one good example I gave you, for example, that was what we called in this one. I gave you an example of like intelligent agents are there. They are again based on the AI techniques are now. I gave you another example that the Yahoo engine is based on this one, all this one. So that is part of, yes, that is part of the AI techniques.
All other components of artificial intelligence apart from expert systems?
Because maybe I listed in the beginning, we have a natural understanding. Natural language understanding, that sometimes computers can understand the natural language, like they can understand the French, they can understand the English, they can understand any other such languages. You can do the processing in that one, right? So that today you ask the query into certain, you can ask the query, there are certain machines who are talking to you also, speech recognition for example, that are also somehow related to these areas now. Right? So this is one such area. The other is called pattern recognition. Right? I want to, the purpose of the, and then many are overlapping areas. Sometimes the pattern recognition should not be a part of the AI. But it is very much part of the AI system. For example, they try to recognize certain objects. For example, if let's say certain body have been presented into a computer, then try to find the nose or let's say the eyes and something. So they recognize certain patterns and so on. So that is another important area of this one. Lots of research in Japanese, because in Japan, they work with own language now. But they have lots of alliances with the foreign companies now. So they basically machine language translation. That is another important area. So you feed everything into one language, let's say in English, and the computer will translate them into Japanese. That is another important area because you have to understand. If you take example of in English now. In English, you have lots of words are there. They have a different meaning in different context. You as a human being can understand, right? But how does computer will understand? So you have to have a appropriate mechanism to represent that scheme and so on. So machine language translations, that is another important area. Natural language understanding is another important area, and so on. So these are basically pattern recognition, machine language translation, and what we call them the natural language processing. They all are the part of the this is a very big science. But when you come to third year, you give you some more details about the. Today you are aware of what is this one, how you can represent the knowledge and so on. But some more representation schemes are there. People are trying to find out the limitation of this knowledge representation schemes are there. So now they are coming with a new technique to represent the knowledge much more precisely than what we have. So when we study AI, means studying the most important component is the how to represent the knowledge, right? Then again we go to the different area. You require a little bit of knowledge of mathematics also and so. Yes, please.
What is the basic conventional program and expert system?
See, I have given you the, I explained this concept is that see, normal conventional programming language or conventional software are, they deal with first, they deal with the mode on the numerical side, they deal with the numbers, numerics. So they are more famous for numerical computing now. Whereas in expert system, they deal with the, what we call them, they deal with the symbols now, right? This is one such difference. The second such difference is that the, and that is the major difference, that it able to, the expert system software is able to deal with the, even if the information is not very precise, right? They have the, they show the intelligent characteristics of the human being, whereas the normal conventional programs are basically built for the computational or calculations purpose and so on. So I give you an example of a chess playing now. So today you have seen that sometime as 1 year or 2 years back, the IBM has developed one machine which played a chess with the Russian, I think I don't remember, yes, and somehow the cook. So basically, he was watching, that person who had designed the chess program had been watching how does that person play the game, and accordingly he designed the whole system. It might not have played the same way another could have done. So depending upon how you have programmed, the human expert will also be here. Yes.
So what is the relevance of data modeling?
The database application. Remember, the question is, if I have understood correctly, that what is the use of data modeling in database applications? This is the question now. Last time I gave you one such technique, in what we call them ER diagram now. Actually, that the best way, what you have to do is that if you want to become a good professional today, software professional, then first you do the analysis. This is the mantra you follow all the time. First you do the proper analysis, then you do the design, then you do the actual programming and so on. For the small program, you have to go to the system and do something clean and get the program. But if you are working in a team work, somebody is doing some part of it, or the time is going to take lots of time and so on, then it's better if you do the analysis. Coming back to his question, that if you don't do the proper analysis, there might be many problems at a later stage. The program might not be optimized, my program might not be efficient, and so on. Or you have to do lots of maintenance job at the later stage and so on. But if you do the analysis, for example, do the ER modeling, one advantage of the ER modeling is that you will understand at the analysis stage how many tables you require, what are the relationship among these tables are there, what data is redundant, what data is not redundant. So how you can do normalizations at a later stage. If you don't do the data modeling for database applications, it might happen that your program will require redundancy it will be created. Normalization might not be playing important role there at that stage. So if you want to do data redundancy, remove data redundancy, right? Capture all the semantics very well, then you better do the analysis. Analysis is otherwise very much important. Not only in the database modeling, in object-oriented style also. You have to understand how many objects, relationship among these objects, dynamic relationship type of things.
Does all expert system require explanation subsystem, or they can work on?
They do. If you work with any of these shells now, they have explanation system sub-model. For example, if they ask you more information from you, they must explain that what for they require more, whether they are not able to come to the conclusion, or if they have given you certain goal or certain result, again they must explain you on what basis they have come to these conclusions and so on. So they must. So this is again important. I don't list them as a separate model, but when you, in most of the expert system shell, this is one such model. What we call them, the explanation sum model, but which is somehow related with the inferencing engine itself. So still we have 2-3 questions you can have asked.
So by networking increases the processing power of the system.
So
in the computers we do the networking. So it basically increases the processing power. So how it is increased?
See what happens today, the question is somehow, you try to understand the question, is somehow, let me rephrase your questions, that will be much more interesting today. Today you see what happening is, it is become with the networking, we have come to a stage of processing bottleneck. I mean, the question, let me rephrase now, if I have understood the question now. So today what we have is, most of the systems we are having networking cards, NIC what we call them, Ethernet card or the ATM cards and so on. Now they process so fast, you understand, that the CPU is not able to process that data. You understand? They are, like take example ATM cards now, right? They work with 100 Mbps per second. You understand? So what happens is that the data transmission by these cards are much more faster than the actual CPU can process data that fast. So what happens, what we call them processing bottleneck has come in the systems now. You understand? Even if this CPU is not processed, or moment it is processed, already dispatched to the another node and so on. Again the ATM card is sitting idle now. So the CPU is not able to match the speed of this networking and what we call them processing bottleneck. So different technologies are used. So for example, ATM, why ATM works faster? This is basically what they have a fixed time of sale. The switching is very fast. Each packet is of same kind. The size is same. Same. 53 octets or what they call it. Right? The switching time is much more faster. Other way, not yes. Not that. Again, that is also, there are many factors which increases the speed of the network. But one such as, I give one such example. Why ATM works very fast. One such reason for working ATM to be very fast, the rest of the technology, but the switching time takes very, very less time. Better. This last question now.
So this means idle time is reduced.
Where?
Say in the ATM machine.
The transmission time is much more faster, right? But to take example of the CPU is still not able to match the speed of the cards now. So again, the very processing bottleneck is there. The system is idle now, not able to do it. Let's say for example, the CPU works very fast, and all the time it has to take a data from the memory now. If the register which directly works with the CPU is not so fast, so what will happen? The CPU will sit idle now. Right? So whenever you design any computer system, you have to see that the speed required by the this one should be matched by other supporting this one also. Anyway, I think we had some good interactive discussion. I think what I request all of you is that you become the core group at your TLC. Whoever is attending our center, the basic purpose of this discussion was that you call in here and we could have a discussion in a similar format in the TLCs also. So you can become a core group at your TLC and you can have some discussions among your colleagues that what you learn here. If certain questions are again not able to answer to them on this topic, again you bring these questions and we'll try to answer all your questions here. Thank you very much.